Hello, everyone, and welcome to this event organized by PMI Switzerland. So first of all, I have a couple words about our sponsors, these companies that are helping us make this event possible tonight. So PwC Switzerland, this is the leading audit and advisory company in Switzerland. It's a network, PwC is a network of firms in 155 countries with people committed to delivering quality in assurance, advisory, and tax services. And our broad sponsors, STS and Pro PMP, deliver project management training and tools in Switzerland. So welcome again, everyone, to today's event organized by PMI Switzerland. So this should have given a couple of minutes for everybody to join. All right. And we'll be speaking tonight about data-driven decision-making, potentials and risks for project managers. And our speaker is Rodolphe Dewarrat. So before we start, hey Rodolphe, thank you for being here. Before we start, we have just a couple technicalities to go through. So since this is a webinar, all attendees are being muted and interactions should be done via chat and Q&As as well. This session is being recorded and will be published in PMI Switzerland YouTube channel. The event slides will be sent to you in a post-event email. And if we don't have time to go through all the questions, we'll include some answers in that email. So there'll be also a Q&A session, of course, at the end of this presentation, and you can post a question, like I mentioned, in the Q&A, using the Q&A feature at the bottom of your screen. We'll also have polls during this session, so you are highly encouraged to participate. If you have any technical issues, please send a message to the host via the Zoom chat. And last but not least, we'll have a 15 minutes networking session after the presentation for you to continue the discussion with Rodolphe and also to interact with the PMI brand ambassadors. Just a note that if anybody has trouble getting in, it's important to enter using the same email that you registered with. So first, let's go through a few polls. So the first poll is about, please tell us where you're joining us from. So you should be seeing a poll on your screen and please select the relevant options. We see a couple leads moving, perfect. Give it a couple more seconds. Great. So I see, of course, no surprise, the Zurich region is really strong, Romandy as well, other parts of Switzerland. So we're still having a few more entries, it looks like. Could I already see IT, pharmaceutical for the second poll, which industry are you currently working in? IT and pharmaceutical are really strong. Financial services as well. Manufacturing. No surprise, I would guess the science is really used in those sectors. All right, it's been already 1 minute. Are we finishing the poll? Yeah, okay, sounds like. All right, we got the results of the poll. So yeah, Switzerland definitely is the top participants, Zurich first and Romandy, and then other parts of Switzerland, a few people as well in, a percentage of people as well in Basel, it looks like, Europe as well, and Asia and Pacific. Okay, well, nice to see you all joining tonight, thank you. And then industry, so the highest yet, like I mentioned, the trend was already right. IT, and then pharmaceutical, and then we have financial services, consulting and manufacturing after that. A little bit of healthcare, consumer goods, life science, government, NGOs, and as well a section others. So it looks like we could refine potentially this poll. Great, thank you all for answering. This gives us a better idea of where you're located and what you're involved in. Thank you. Let's close this. Oops. All right, so let's dive in. Tonight is about data-driven decision-making, opportunity and risk for project managers. So a couple words of introduction for Rodolphe. After studying mathematics and chemistry at the University of Freiburg, Rodolphe worked at the University of Cambridge in the UK during a postdoc in electronics engineering. His interest in interdisciplinary projects brought him to data science, out of which he created his own company, IMSD. And from the start, Rodolphe was also interested in project management, and he's been a long-term collaborator with Karine Galli, founder of Cubisma. And so Rodolphe is also a lecturer at the University of ETH in Zurich on the topic of project management for researchers. And I've had a preview of Rodolphe's presentation, so I think this will be very interesting. And this might trigger some interesting questions and possibly larger discussions about the role of project managers in the near future. So look forward to it. And with that, I'll hand it off to you, Rodolphe.
Thank you, Valerie, for this introduction. I'll take a second to share my screen. The best thing is to start directly into the topic, and then I'll explain you what we do. In many journals and articles, television sessions, and maybe even TED Talk, you hear a lot of things about modern manufacturing, modern processes, modern project management, that all the data comes, goes, jump, and goes through, and is being used for having the processes to be more efficient, to reduce used resources, and so on. The reality, it's only in 1 or 2 movies that things like that really happen, like maybe Mission Impossible. I think the aim of today is to try to explain you, or to show you my point of view on this topic, in order to understand why it's only happening in the movie. So welcome for this session to data-driven project management. The first topic I will cover is to say a word about my company. Surprisingly, the acronyms of my company and PMI Switzerland are quite similar. It goes even a little bit further. Second topic is, why is industry, manufacturing, or project management 4.0 not completely yet there where we think it could be or it should be? We talk about what can be done, of course. And then I think it's nice, maybe not for all of you, maybe for some of you that are still trying to think how to make progress in that direction, to hands-on, so to really see what is a data scientist doing and why, and how is he working. We'll talk a little bit about algorithm, artificial intelligence. It will also a little bit depend on Paul that will come in the meantime, to see a little bit the background of yourself. We'll jump to some conclusions, some questions and answers, some questions that you may have. Don't hesitate also to ask questions during the presentation. In the background, they will be moderated, and I requested the moderation to jump in if some question is really urgently useful to understand the content, also following slides. Otherwise, we can answer the question, or I can try to answer the questions at the end of the presentation. PMI Switzerland IMSD. So you see on the right, you have this acronym of IMSD, Institut Multidisciplinaire of Science of Data. Of course, it comes from French. It's a little bit less awkward in French. Institut Multidisciplinaire de Sciences de Données. So we have the same institute, we have the same kind of things. Surprisingly, we even share some of our corporate colors. It's a pure coincidence. It's like that. As you heard from the introduction by Valérie, I studied mathematics in Fribourg, and I jumped to already engineering in Cambridge during my postdoc. Lately, I have been joining two different startups in medical engineering and energy engineering, mainly in Zurich. At the time, I was doing data science, but terminology data science did not exist at all. So we were just doing data analysis. Later, I joined one of the companies that is here lower in machine industry. I joined a spin-off of this company to become really a data scientist and as a consultant. And finally, 2012, so I'm celebrating a birthday of 10 years, I decided to do this by myself and to start a company called IMST. I've been having some offices, shared offices first in Zurich, then I had offices in Lavaterstrasse, just behind Zurich buildings in Zurich. And now for kind of family and medical and also COVID reasons, I resized a little bit the company and I moved to Fribourg, where I'm at the top of this picture, where you see the lights. It more or less looks like that, not quite yet because it's a little bit not so dark at the moment. This is top level. It's a building of the chocolate factory Villars in Fribourg. The chocolate fabrication has been moving to another place, and many different companies are sharing some of these places in kind of old vintage style. Here in Fribourg, it's close to the universities, which is also quite interesting. Company IMST is doing data science services. We do data modeling, a lot of data visualization, because I'm convinced that probably we can get much more insight into data by doing excellent and specific visualization. And on demand, we do modeling, artificial intelligence, and things like that. We are also specialized in science communication, doing some kind of one-to-one consulting for scientists that needs to make some public communication. And I'm giving a project management course at CEST, as Valérie said already, in collaboration with Karine Cali. So back to the topic. Why does it only happen in Mission Impossible film? I think there are mainly three reasons. And surprisingly, while preparing this event, we had a chat about the previous event of PMI Switzerland. And one of the event was mentioned, this presentation by Boris, almost exactly 1 year ago, where he was talking about the artificial intelligence buzz. And I totally join his view, and I will try to bring you my insights into this point. It's important, it's happening at some places. He's also been mentioning that, but in general, as a society is not yet there. The first reason is probably that IT infrastructure is kind of still imported from last century. If you go into companies, I've been visiting smaller, bigger companies, they are completely organized. They have databases, they have their backups, they follow the data, they do everything. But everything is segmented and has never been sought to communicate. So this picture that is down here that I've been creating almost at the beginning, at the creation of IMST, of exporting all the data of each process in any kind of process, from the suppliers, entry control, settings. Also, environment data, we talk about pressure, temperature, winter, summer, day, sunshine, quality control, costs, project management data. At the time, I was not thinking about that. and both together to kind of make a data fusion process in order to be visualized, to do this analytics or data science or artificial intelligence and get some information, some insights for better action, for optimization, for suggestion, anticipation of the future of the company. It's most of the time not really working because things are segmented, they don't communicate together. When you have one entry for a specific product, you have 10 on the other database, and maybe these 10, they are shared with 2 other entries of the first database. So in general, whenever you go into a data science project, you see it's a huge, I want to say mess, but it's not a mess, it's organized, but it's highly complex to put all this data nicely together in a way that you can do analytics, that you analyze them, visualize them, and get something out of it. And the costs of all this preparation has to be balanced with return on investment. You have an investment of a few thousand, 10,000 millions, and the return on investment cannot be estimated. That's the reason why people are not always working in that direction. Second point is, even if you have the data, usually quite some of the data has quite relatively poor quality. I can give an example of consulting that I was doing about 2-3 years ago in a Swiss cantonal bank, and we were trying to find out which customer of this bank is likely to buy a house next year. If you don't have correct information about the customers, their marital stages, whenever they get divorced, nothing happens. It's never kind of described in the database. If you go into it, and you find children that are retired at almost 65, you find customers that are deceased and still have pay accounts, you find all kinds of things. And as long as the data is not correct, the bank can still work. It's, let's say, daily business, but doing a big analysis to try to estimate which customer is likely to buy a house next year, you need to have these things correct. Otherwise, you just analyze data that is wrong. And then all the settings in the algorithm, all the optimization will be based on wrong data and give you wrong answers. One interesting thing about this project, later in the slides, I will suggest you the way how I suggest to go in this project. And while doing that, they were exporting first a part of the data, sending it to me, and then they say, Rodolphe, let's meet in 2 months when you have the first results. And I had some results, I did a ranking, I was trying to find out which of these customers are likely to buy a house next year. And then they said, okay, let's look at the ranking and let's find the first few ones and just really analyze if they are reasonable, if they could be called by our call agents. And the first one, they were trying to find him and said, we don't find this guy, he's not the database, he doesn't have as much money as you say. And they were kind of puzzled. And searching a little bit further, they found out that the guy had just been buying a house. So he completely changed his status. It was not fully documented in the database. The guy was at the top of the list. So data science works. It just needs to work with reasonable data. The last point is the more tricky part. It's really related to the way people work together. And there is, in many industries, still a little bit of mentality of the industrial revolution, of having different levels, people with different targets, and not all people being really conscious about sharing the same aim in the company to get the best product, the best quality. So typically you visit a flight industry company, and the question we were trying to solve there was to reduce, with the project managers, the re-engineering time. So any process being done, like drilling a hole on the building site of an aircraft, has first a process step and then a control step. So another person is coming and checking the hole at the right time, at the right place, and things like that. And if it doesn't fit, then there is re-engineering. The hole has to be maybe filled at some place and redone at the other place. It was for electrical connections. And we had a kickoff meeting of a reasonably big project with all the experts from different topics. And everyone was telling me, I have a database of this, I will send it to you, export it and send it to you tonight. Another guy, same thing. And then they say, okay, Rodolphe, let's meet tomorrow to see what you have seen in our data. The project was going a little bit longer, but second meeting was already on the next day. Just when leaving the room, the main project manager came to me and said, Rodolphe, I'm sorry to have to inform you, you will not find any information. This is all this data. I was a little puzzled. I didn't understand everything. He tried to explain. I couldn't understand. After working some hours or some days on the data, I realized that the working people in the building site, they only start filling the reports when the quality control is over. So in the end, we have only positive results. We have zero re-engineering. They are not visible. We just see that some of the processes, they take days rather than hours. That's the only thing we see. Sometimes when the process is taking longer, people just associate the extra time that they needed to any task of the day, but not to the specific re-engineering that they did 3 or 4 times of these electrical connections. So as long as not everyone on the building site is convinced that his work and his activity and his reporting is useful to the construction of an Airbus, it's not going to work, and it's not really meaningful to start data science in a large sense, because people will try to trick it out and to say, okay, we just have to fill more reports to show that we're working more. So we really need data that is correct and connected to the process. Let's jump to maybe 1 or 2 further examples. The first project I was working in when I started as a data science consultant was in the machine industry. And the idea was there to help the CEO to estimate in advance which project is going to make in the end a positive margin and which one is going to bring a negative margin for the company. It's this margin is a little bit a random process for the CEO. A process typically in big machine industry takes, let's say, 2 to 3 years, and the CEO is completely blind. The project is continuing. The project manager is updating on a monthly basis every information. He doesn't have any tool to estimate what is going to be the margin in the end. And the reason is because we were saying, okay, if the project manager are giving you some updates on a monthly basis, you should, from these updates, make an estimation. So how far are you from the estimated cost and duration and time? And when I'm getting into the data, we realized that until the last month, 90 or 95% of the project, they basically don't change the values, the cost, so it just grows linearly. And on the last month, it just jumps in order of magnitudes upwards or sometimes also downwards. So the project manager, of course, they are busy with many projects. They may not have the time to go into the details, and they just copy-paste the data of the previous months. They add a little bit of cost, and it's fine for this month. We will see next month. And then there is a fully focus just 1 month before the end to estimate what are the costs exactly, and is it a positive or negative margin. So all this kind of project management information was totally useless. What we did then to still get some information is we imported all the information that the company has basically on the day the contract is being signed by the customer. So we know what is the machine going to be built, where is it going to be built, what is the customer, is the customer a new customer or customer that has been working with the company already quite often. We know much more details about the size, especially also about which department is going to be involved in the company. And then we try to fit this data with the final value, plus 10%, minus 10%, plus 20, minus 9. And then we start finding out some information. Of course, I'm not going to go into the details, but suddenly you see that whenever these two departments have to collaborate on a project, it always goes wrong. Whenever the project is being sold in this country, it also always goes wrong. Whenever this step is taking place at that time, it often goes wrong. So you start getting some more insight into the data because you have validated data. All this data that I have been mentioning is more or less contractual, so it's good quality data. Another project, completely different, also completely different time. It was 1 or 2 years ago. Swissgrid is a provider in the electricity in Switzerland, and they are responsible for all high voltage lines in Switzerland. They do some project management to estimate what are the most important projects in the future, and they also make a prioritization of this project. Which one do we start? Which one can they put aside or delay in case something happens, in case it's not really going to work within the time frame that is expected. Think about the fact that the time frame is 25 to 50 years from now. And one guy who is retired in the meantime, he was saying, yeah, these priorities, they are set based on some estimation from excellent engineers of Swissgrid about the project, so the importance for the population, the risks, the costs, the duration, and the risks. He said, but what happens if these engineers, they have some estimations that are not exactly correct? Maybe you take another engineer or a colleague of him, and you will get another estimation. And we started to replace or to allow every entry into this prioritization process, not to be only one value, but value plus minus, so to have kind of error margin. We see the small triangle in the lower part of the poster. So we have not only one value, but it could be one value lower with a certain probability, or 10% or maybe twice bigger with another probability. And then we say, okay, now suppose that each of the entry can have this error. How is the priority list going to change? And we could see quite important changes. So the priorities, they were jumping from one extreme to the other extreme, just depending on small variations in the inputs. So be very careful about the quality of your data. Otherwise, you do nice analytics, nice mathematics, nice data analysis, but that has absolutely no founding. And the last one I wanted to share with you is one with a company called Feller. They are specialists in Switzerland for electrical plugs. And I had the contact with a sales manager, and he said it would be really nice to make some estimation about how many pieces are going to sell of the main pieces that we sell next year, month by month. I said, okay, we can try to figure out what are the influences and try to make this estimation. While trying to figure out, we found out that, of course, there are some seasonal variations because these devices and plugs, they are mainly bought for the building in the industry, and the summer is not working exactly as the winter. One huge influence that needed also quite some modeling is price changes. As soon as Feller itself is changing its prices, some of the resellers of Feller, they buy in advance quite a lot of stock, taking advantage that the stock price will increase and that they will be able to sell it at a new price a little bit later. And then it makes a huge wave. Before the price change, they sell more, and after the price change, they don't sell during some months. This is a major influence also for the monthly estimation. And we had some other, like currency exchange with euro for other countries and things like that, influences that are possible. We made an estimation and let it run. And after the first year, the guy called me back and said, quite happy. He had a deviation of 8% between what I was estimating and what was the reality. And he said, 8% is nice, but it's not good enough for us to really adapt our sales or our production. But we would like to go to 5%. And I told him, no, with the quality of the data you have, I don't, it will not be possible. He said, okay, let's try next year and see what happens. And the next year was a year where the National Bank decided to stop the fixed exchange course between euro and Swiss francs, which made a huge wave that was not at all in the model, that never happened before. So all the models could be thrashed, and it was everything for the bin. I would have liked to do it. Yes.
There's a comment saying the whiplash effect on supply chains. It sounds like
exactly
what you're describing, right?
Exactly.
Thank you, Joaquin, for this comment.
So now maybe I've been too pessimistic because I'm a data scientist and I like what I do, and I say I destroy it, it doesn't work. Yes, it works. It still works, and some companies are making a huge amount of money with that. We'll see why a little bit later. I think there are some solutions in the meantime, and my recommendation also when you are a project manager, when you plan maybe an involvement of data science and it's not completely clear to what extent, start small and start with a feasibility study where you work with offline data, as in this bank. It doesn't matter. You don't have to be just in time, just for this feasibility study, and you'll get some insights, but work with real data and challenge the outputs. And after this feasibility study, you will have a much better insight. How much work was it to import the data, to treat the data, to do this processing of this 80% of not messiness, but of unmatched data, and is what comes out useful. So is there going to be in the 8% quality that I managed to get to Feller, or is it going to be useless? When you have that, you are ready and you have the tools and you have the knowledge to make a good analysis. While preparing this talk, we were also with Valerie a little bit looking through what is already available about data-driven decision-making. And one of the resources here visible on the internet, and they say exactly the same thing. Yeah? You start doing, you collect, you prepare, and fill any gap. in that case, they suggest to start a big project and to just fill the gap. Keep in mind that filling the gap could be more expensive than any return on investment that you are expecting. So make your gap analysis based on the feasibility study and not on the full study. We'll be able then to evaluate the cost of filling the gaps, once again, the potential, the return on investment, and also some indirect return on investment. Many companies, they have some needs to be able to show that they work in a modern manner, that they apply modern methods. So image is also important, internal communication. And the last one, which is probably even more important, which is also probably even more relevant for you as a project manager, because I think you are the key person to help on that thing, is work on the soft skills and communication with everyone in the company, from the starting kind of technical staff up to the management. This is probably a challenge, but this is a challenge for you as project managers to not leave anyone behind, get everyone conscious about the aims for the success of the company. It's the same in the project management course that I give at the ETH. Every time we have discussions from PhD students that say, this technical and administrative people, how do I manage to motivate them and get them to work? It's not like that. These are people that are in a completely different position. They have a long view of their kind of work or career. They want to stay there 20 years. A PhD student, he wants to stay and to get his PhD within 3 or 4 years. But they have been here already 20 years ago. So they know all the details of the running of the machine. They can help the PhD student avoiding to make some big mistakes, working correctly with the machines and with the things. But it needs this exchange and this work to consider everyone, consider through this kind of methods that we present, as you probably know, of empathy maps, what do people feel, hear, see in their own, as in their own position. Needs and fears, and also stakeholder analysis, who is where and who is going to go where, or who is willing to go where. I think this is really a key element that is extremely important for correct data science. There are one or two situations where I could show that. I was working once in mechanical engineering in South Germany, where people do some devices for aircraft or for big ships. And these devices are a combination of mechanics and high-level electronics. And suddenly the yield was going down. They had usually 95 to 95% of the devices that they were able to sell. So fulfilling the quality requirements, it was going to 30%. They called me because I'd been working before with them and said, well, something is not right there. What's happening? I was personalizing data, trying to challenge the data that is available, not investing too much time in getting some further data. The first things that I realized is that whenever they do a quality control, it fails, they redo it. And everyone should think that if you have a device that has been failing, its probability of failing again, it's quite high the second time. But it was reducing. And the third time, it was reducing a little more. So in the end, they were managing to sell all the devices because they were testing. And I was saying, okay, so there is a statistical reason behind that it could explain that, but it was far away from statistical values that you could expect. Something else is playing a role. And then I was walking through the company, and the guy, close to retirement, not talking too much, So as a data scientist, as a project manager, you have to talk with the people. I was saying, whenever we had in the past devices that were not so good, I must explain that I noticed in all the data that I received, that was a small voltage value in the middle of the process that was kind of sharing the two set of devices. Lower than a certain target value failed, higher was good quality control. So I had a value that basically had no relevance for anyone in the company, that was kind of helping me to select these two groups of devices, the good and the bad ones. And then I went to the guy kind of measuring this value, and he said, yes, in the past, when this value was too low, we were putting the device in the cellar, in the second floor underneath, and letting them run about 2 weeks. They were getting hot without any cooling, and then they were fine. Okay, I said, and there was improved quality management, and we could not explain why we do this, and they decided to remove this step. And now we don't do it anymore. I told him, now I know everything. So I could, with data science, kind of give justification for this kind of steps that was coming from the guts of the people in the company. And they had a kind of feeling, when this voltage has not the right value, some of the motor is not completely smooth, and a little bit of working is going to be this polishing on the surface, and maybe brings the device to good quality. And this is what has been implemented, and the problem was solved. So good for the company, not so good for me, because I had no more project for this company, but it works, data science works. At this condition that you get the data have reasonable quality, and finally you talk with the people. So you will not, maybe the data scientists will not only get the data, the information and the solution from the data. You need also this extension and this soft skills ability to go to the people. Voila. There are solutions. That's what we try to explain to the PhD students at ETH through this course that we give in alternance with Karin Galli. She has been writing a book about that, Project Management for Success in Research. It goes through a little bit of methods of doing stakeholder analysis, different types of analysis and Gantt charts and things like that. The methods, the students are absolutely fine with them. They are used as engineers to learn and to apply methods. When we go into soft skills like anticipation and solving of conflicts, improving communication, getting everyone involved, understanding the needs or fears of people, and the people start thinking a lot more about what they do and how they work. And I hope that the future engineers that we that are being educated there will have this vision, because in the end, when they will be out, most of them, they will be project managers, even without maybe full education in that, but they will manage projects and they will not work on the bench and work in the factory. So I think this is really the important thing. So we spent, I would say, 30% of the course. It's a course, a block course of about 3 days on this soft skills. Let's jump to part 2. I've been chatting a lot. Maybe you want also to be a little active to say, but why, how do I do it? How can I manage it? I would suggest if the back office is helping around, that you pop up here the 3 questions that will a little bit help me to understand what is your background, what you know already about data science, about things. So I have 3 questions here. You can scroll down if you want to see the third question. What is a CSV file? Have you ever heard about it? Do you know how to use it? Have you ever heard about R and RStudio? you can answer roughly what you think about that. And what about the neural network? So you can choose one, what you think about it. Is something happening in the brain, or you just already apply the things? Take a minute to think about that, to answer this, and we'll get probably from the back office the statistics very soon, and it will help me estimating more or less what I have to talk about, or if you get bored about what I explaining, try to show you, present you. Oh, you go fast. Of course, very good. So everyone knows what is a CSV file. I have some others. Well, 26% say have some idea. It's basically a text file where you have your column, like in Excel, you imagine your column separated by a unique separator. And it's a very convenient way of importing and exporting data from databases and through Excel and like that, also for doing data science. So in this feasibility study, in order to speed up this kind of data importation, export everything as a CSV, and let the data scientists work on that. This is also what is happening. I'm still working with this machine industry company. They want to make some estimation about their sales of second-hand, not second-hand, but repair parts for the future. And we analyze every year the spare parts that they sell, some motors, some part of the machines, and as they are selling worldwide, it helps them estimating firstly what is going to be the needs in the future, and also how important the competitors are trying to sell spare parts in a lower price.
You can see. Okay.
I have
Thanks.
it perfect. Yes. Okay. Using from time to times, never using it. So most of the people are not using it. That's what I'm going to show you how you can use it. And the neural network, this is what I was expecting, is that most of you have heard about it, but you don't really know what it does. Also, in the previous talk 1 year ago, there was not much being said about that. Of course, I cannot go into the details. I will still try to make sure that when you leave, you have some idea about it. Thank you so much. So my suggestion is to jump into one very specific minute of the project management course that we give. We want people to simulate a pitch of a project. So they try to sell their project, and then they have to simulate a kickoff meeting of this project where they involve external stakeholders, also the local police of Zurich in this situation. So I invented a kind of project based on some kind of reality, saying that there is a technology and it exists called quantum radars. And why not put these quantum radars in front of buses, especially on the line 32, which is a kind of heavy traffic line in Zurich, where all kind of activities happen day and night. And so, of course, these quantum radars, they are very good. They measure everything. They are able to figure out many different elements. And then on top of it, you have, sorry, excellent artificial intelligence that is basically as good as human brain or as good as a driver in figuring out what is happening there. So it can identify any kind of obstacles of things that are around on the road, and then allow safe driving in any unexpected events. The plan of the project is to replace from the 1st of January 23 only one of the buses of the line 32 with a self-driving bus. of course, with someone inside for security and blah, blah, blah. And then 1 year later to have the full line replaced by self-driving buses with quantum radar. A funny thing about that is that when we do the kickoff meeting, I always involve people from the so-called pro-velo association, so the cyclist association in Zurich. And I was expecting when I created this exercise strong opposition from this group saying it's going to be dangerous, they're going to kill us, and like that. And most of the students, they take a completely different position, and they say, no, it's going to be safer because bus drivers, they drive like crazy, so maybe going to be safer if if it's no more a bus driver, but it's a quantum radar technology that is driving the buses. So you see also the mind of the people is evolving maybe even faster than the reality. Let's jump to one more specific part of this exercise. Each of you will take 2 minutes to estimate the costs of this phase. Of course, you're missing a lot of information. In science, it's very often like that. People, they have to apply for project to the Swiss Science Foundation, and they have very little information. They know basically nothing about that, just know what they want to do and what they dream about. So the phase is just to replace from the 1st of January 23, one of the buses of line 32 with a self-driving bus using quantum radar technology. You suppose that it has been already kind of developed in the labs at ETH, but it's not ready for life. To make some data science out of it, you use chat to communicate with us, and you just write one line. You take your surname or you invent a pseudo, it doesn't matter, and you put a semicolon, and then you put just the amount in Swiss francs or in US dollar if you are abroad, it doesn't really matter. I just want a number. So is it 1 or is it going to be 10 millions? Take 2 minutes to write that. I will just follow the chat and we paste that and we'll do data science with this data. Voilà, you are with me again. Now you even see me and Valérie maybe twice, doesn't matter. Okay, of course, I was a little bit preparing myself for this exercise, and I was making a kind of prepared file in case things go wrong. And you see here on the left, the prepared file. We have a name and we have a value. If I try to save this one, I go to this RStudio. So RStudio is an interface for using R. R is let's say an engine doing calculation. You can compare it to MATLAB or even C or Python that is very often used. It's open source, so the engine is kind of separated from the graphical interface to use it. The graphical interface is developed by a company, so it means that first you have to basically download R, the engine, to install it. You Google download R and you find it, you install it, and then you Google download RStudio, you open it and you find it, and you get exactly this view when you open RStudio. We could do it in real time, but I think we want to move forward. The only thing I have to tell them is where is my data. And my data is wherever we are at the moment in Project Management Talk 222. It even tells you, okay, this would be the line of code in case you want to put it in a code for the future. And then I was thinking about, because I have prepared also my code lines somewhere. Typing this one, we import guesses of the customers. So the guesses of the participants, just read a CSV file, and it's called guesses.txt. Sorry. Now we want to see what is inside. And we see it's possible to read that. You cannot start anything, because I was expecting something like this file, so the value, name, the value, and what you provided is something like that. Of course, for any human, it's no problem, but for a computer, it's impossible. So let's put one S vault, avoid the pointer. So, and we have unknown. And here we have a double colon and not a semicolon. So the computer is also going to complain. And then we have this one, it's done. Hide a semicolon. Hide a and we have Stefan.
Indeed, Rodolphe, I see on the screen in the file, 2 Florians, yeah.
Yes. We have unknown 2. It's 300,000. We have 4 million francs for unknown 3. We had 4 millions with the units. Flow. Here it's almost correct, semicolon, and blah. See, out of something like 20 answers that I have, only one is kind of following the requests. So imagine real life, people, they are not thinking about data science, they just deliver data, deliver. It never works. So this work
we have a comment.
Yes.
Stephanie saying data quality is important, but the requirements should be known to those providing the data.
Exactly.
Yeah.
So it looks reasonable now. Tac. So we try to import that again. Oh, now we can start doing the data science. So we want to have maybe bar plot. See a little bit how it's with a spread of the answers of all guesses. And I have to see what column I want to display so much. And to see it like here. So you already see. I have to move my. Oh, I have lost my view. Voila. There is quite common understanding for many people saying that it's about a few millions. And we could even do one more thing. Box plots.
I think I put too many zeros, Rodolphe. That's my fault.
Maybe, exactly.
That's mine. That's my entry that's causing the whole.
Yeah.
To spike up.
And here you see that directly. You have a kind of average here. If you go into details, you get about 5 million in average. And here you get one that is 10 times faster. So data visualization, you don't have to look on the left at the data and how many zeros and then get confused. You just get this one. Okay, it's completely out of focus. You can remove it or correct it or go to the person and then find it out. So data visualization is really the solution. Go back to the slides after this exercise. I hope, yes. So
great illustration. It's cool to see a working demo live. Good job.
Thank you. I stop sharing and I share again just the slides. Voila. We analyze the data after installing RStudio, reading the inputs, display them, and we could even do some normality distribution if I had been taking into account all the answers that you gave. I said here on the left, many of you maybe are not using R and RStudio, but they could use maybe Tableau in their own company, or they can use MATLAB or Excel or Python. Example at Feller, it was all done in Excel after some kind of pre-processing in MATLAB because I had to do some simulations before. But then the final product was all in Excel. We have it in R. In fact, now if you redo later, when you follow the video, what we are doing, you will see that you are able to read files to fit the data together, and you're becoming step by step a data-driven project manager. But it's not only that in data science. Data import, preparation, visualization. Imagine now you are a real investor, and I would try as a student to know everything about you as participant, as a real investor. So I would not only ask you estimation, but I would try to find out your name, surname, your IP address, your LinkedIn profile, and which website is citing you, maybe which YouTube video is going, in order to be able, if I don't know you, to anticipate your guess, and me as a student to prepare my pitch in a way that I get exactly, I say I want 4 millions and you were thinking about 4 millions. So this could be based on simple rules. I say in average it's 3.5 millions. If the investor has an MBA, we increase it by 30%. Because we have seen that many investors with an MBA in their LinkedIn profile, they were rather higher than 3.5 millions. If there is science in profile, maybe less 20%, because we could have seen in the data from LinkedIn that people that have a PhD in natural science, they are low profile. They know it's not going to be so expensive. So it's different. And these rules, they can be found quite easily with very simple kind of classification algorithm. It's not so difficult. But if you want to import everything like website, like LinkedIn, like YouTube video and things like that, you need much more advanced algorithm that as input, you can basically give the full LinkedIn profile and some video information. And the machine is going to combine this information in order to produce a result. So the result, think about a neural network. You have 10 million possible inputs as data, videos, images, text data of LinkedIn profile. And a neural network is only able to do some additions and of two or some of the results, but it can do it many times. So it does randomly, it combines 10 of these 10 million inputs or 20% of the 10 million inputs, does some addition and gets a first guess. If the first guess is good, he gets a bonus plus 1 point. And if the first guess is quite far away from the test group, the neural network is going to get a minus point. Fortunately, computers, they are fast enough to do it not one time, but 10 million times. So 10 million times, he has a chance to get a plus point or minus point. In the end, just randomly assessing some combination of the inputs will slowly drive, with some optimization, to a machine that is able to combine the inputs and to make a guess that is quite reasonable. And that is what all these big ones that really do data science and artificial intelligence, like Facebook and Instagram and Amazon do, because their main business is what? Is not to give you fun and nice pictures and things like that, is to sell you exactly the kind of advertisement and the object you are going to will. As we are millions of people on this earth, we have a lot of data available of us. They just group us and classify and add, and they find, okay, for this guy, we're going to show now this advertisement. If you buy the stuff, they win and they are good. So this is really the challenge for these companies. It's not very scientific because if it's not exactly the best thing that you really are dreaming about to buy, maybe it's the second best thing, or it's another, or one it's completely wrong. It doesn't matter. After 1 or 2 years, you will be buying something. They're happy about that. So for this sales process, artificial intelligence is really performing extremely well and giving good results. Get back to our topic, improving the quality of project management is still difficult because we want precision, we want good quality results, and we don't have so much data available. And the quality of the data is sometimes really poor. This is exactly. So
Rodolphe, just
yes.
we have a couple more minutes left, so if you're able to.
Exactly, I'm about.
Yeah,
yes.
and there was a comment while I'm here about data quality in NLP, the fact that it's a whole can of worms, apparently, speaking from painful experience.
Exactly, exactly. Definitely. The big group of algorithms, they are kind of regression that you heard, linear regression, everyone heard about that about school. And then you try to classify things into trees. The good advantage is visual, you can understand that, but the trees, they are not very stable. So sometimes you get one tree, sometimes you get another tree. And then you go into further things. The first step after doing trees is not doing one trees, but kind of millions of trees. And then getting the average of these millions of trees, and then doing some neural network, as I explained before. I just jumped to the next thing. I think we can jump over these things. There are many data science tools on the market. Surprisingly, R and Python are not even on the list because they are open source, so nobody is trying to promote them. We get to the conclusion. So we have project management, data-driven project management has, I think, a huge potential to use the resources, human resources and material resources in a much more optimal way, reducing the waste of time and of material in every company. That still happens. However, today, for most companies, these structures, they are not completely ready for that, for the reasons that I've been explaining before. Progress can happen step by step. Don't be frightened to become yourself a little bit a data-driven project manager. And if you don't want to directly apply it or show that you do it and things like that, don't hesitate to train yourself a little bit on kind of private data that is available around you for you. Nowadays, you can download the data from the electricity consumptions you have at home. I think it's even by law that you should be able to access this data in Switzerland. You have maybe a temperature sensor at home. You can download this data. You can even start fitting the data because the electricity consumption is probably related with temperature. And things like that, and you will go into the direction of one of the last posts of Valerie recently on LinkedIn about the kind of fundamental skills that help citizens and people to be more ready for the future. And on the lower right part, you have these digital skills that go into data literacy and the ability to just deal with data, maybe not apply artificial intelligence, but understand a little bit what is coming in and coming out and how it's working. That's it. We went. So we have probably time for.
Thank you, Rodolphe. Yes, this is great to have a bit of time for questions. If there are any, actually, because right now I don't see so many coming up. So let me share my screen, and we can keep your screen. Well. Let me see if I can share.
Stop measuring.
Yes.
Voilà.
Perfect. They selected tab. Here we go. Voilà. Yeah. All right. So let's see if we have any questions coming up.
I see one about the fake sense of objectivity.
Go ahead.
I like it.
If you want to read the question so that if people don't see the question, yeah.
Yes, it's definitively a point. I had often the experience that the people were kind of trusting the data that I was presenting much more than myself. And this is an issue where you have to work on it with showing the data quality, doing a lot of data visualization, that people start to understand what you do and what is value. Also not giving only value, but giving kind of error interval of the value and what it could also have come out. I had an experience where once in medical science where we had to go to a conference, and device we were developing had no valuable data. I was doing a simulation, and I could see all the doctors just hanging on the video of my simulations, because they say, the patient is going up and down, and now he's going to have this problem. It was all simulated data, and from that time, I'm very careful about it, and it's a danger for most people that are not data literate. So it needs a lot of communication. Yes.
Yes. Great question. The next question I see is, are there really project managers out there that are anti-data? What's your feeling about this? Are there really project managers out there that are anti-data?
I'm sure that there are project managers that are more kind of gut feeling driven, and it's maybe, especially for the social skills, we could consider it as the old school, but it's an old school that is still valuable. I think data decision driven is a help, but it should not replace the gut feeling. There are also some discussions. We wanted once to do a project in kind of emergency service, and people were saying, also in hospital, people were saying, yes, but we're going to replace the surgeon, no, or to replace the doctor, no. We're just going to tell them that maybe they forget about some issues that is just happening now, because they have never seen that, and some other colleagues in the country have seen that. So consider this data support as a support and a help, and not a replacement. And I think this kind of anti-data is also sometimes helping just to stay in contact with the reality, and not be only at the level of Facebook trying to bring you the right advertisement, because yes, there is no good and right, and nobody is dying because he gets the wrong advertisement. So sometimes you still have to be
as a good
careful.
Counterpoint. Yeah,
exactly.
And would it be more correct? That reminds me of something I read, an article about being data informed, making data informed decisions rather than data driven. So maybe would that be more correct right now to talk about making data informed decisions?
Yeah, exactly. I think that data informed is only probably being aware about the data of the past and doing this kind of visualization. You need one more step. You need still this modeling and anticipation, but in the end, decision has to stay in most cases at the level of the human.
Human, right?
Exactly. Yes.
So, like you say, AI or data science is all coming in support of project managers. So, yeah. Would you recommend today that project managers learn data science? Is that something you see? Like you showed, I think one of the, like in the post I had shared on LinkedIn, you would recommend really for all project managers to start looking at data science?
You should at least be a little bit data literate, in the means that you know what is possible and what is not possible, what is reasonable and not. Then depending on the company you are, the size of the company, maybe you have behind you a data science team of 5 persons, and you don't even need to start doing that by yourself. Maybe you are in a startup and there is nobody around, and maybe you do it by yourself. Sometimes I even also recommend the people, even if you have a team of 5 people behind you, to try by yourself. You do this kind of feasibility analysis on your side, just to get the feeling of the complexity of what comes out, and then you are in a better way. You can much better talk with your data science experts. Right,
be able to communicate with the same vocabulary and understand each other is important. That's correct. Yeah. On the same similar, maybe as a follow-up to this question, I see a question about AI algorithms are indeed daunting. Are there options for amateurs, or similar to, for example, low code, no code options? already? Maybe it's
yeah,
early.
yes, there are some options. I am not very experienced on that because it's not so much in my option, but there are some softwares that have some costs, but that's pretend it's no code, and especially they are drag and drop, so you don't have to code things. If it's drag and drop, it's going to expect that your input is fitting to their drag and drop boxes. So they have to be nice and collected, but there are some options, yes.
Great. Thank you. So I see the next question is, as project managers also have other tasks than just reporting? Yes, there was a comment early on, Rodolphe, I think from Stephanie on reporting. The fact that most often, so you were referring, you had identified issues with reports, right? So most often the issue is that a lot of the reports are not or cannot be automated, thus creating much more work for the people. Mm-hmm. And so the question here is, would you recommend to have data specialists on the project that is doing the data management and the reports? As I do see myself in the role of the data analyst and being a PM, a project manager at the same time.
Mm-hmm. In the interview discussion I was doing with this guy from an insurance company, he was saying that it's now really the trend to have data scientists kind of following, being in the back office of each big project from the beginning, from the planning into then the project realization and into the analysis, and maybe jumping in a little bit sometimes and a little bit more at some other time to be able to evaluate this kind of issues of data quality and to collaborate a little bit better. And anyway, for communication, let's say, purposes, in the end, it will be nice because you have someone to make you nice plots of your data, and maybe you have even chance to do something like that. So it's completely obvious that a project has to be accompanied by a project manager nowadays. Maybe in 5 or 10 years, it will be clear also that the data scientist has also to be behind, let's say, most projects with a certain complexity. If you organize, let's say, a conference like I do sometimes, you don't need a data scientist behind, but it's still quite some project.
Right, depending on the type and the size of the project.
Yes.
I have one more question, which is, I have the feeling, or a comment, question, yeah. I have the feeling that data science is really critical for projects where the analysis of large complex data is critical factor. Think about airplanes, healthcare, etc. Are there other criteria to consider to decide if specific efforts need to be put on the data science part of a project?
Yes, it's really this kind of amount of data that may appear in your project sooner or later. Sometimes people ask me questions like, what kind of measurements should we also do in our production to become better? And this is a limit. I mean, we just work with the data that is around, and then we are human and we can give some suggestions. But data science is not going to make suggestions out of the box of the data. So if you have a project where you are sure you're never going to have, let's say, in a simple way, big Excel sheets or big databases, I think you don't need data science. But this big document, yeah, sorry.
Yes, no, thank you. I think you have it covered. Thank you so much, Rodolphe, for answering all these questions, for your insightful presentation, as well your working demo. We know how usually demo goes, but actually it worked perfectly. So fantastic. Thank you so much for illustrating those concepts in the real thing. So let me see. Yes, so in case some of the attendees want to contact you, you share your information. So if any of you want to connect directly with Rodolphe, feel free to use his contact information. And I love this little tagline, let's talk data. Really, really great. Thank you also to you all for all those questions, for attending this presentation, and for all the interactions you provided. And thank you to our fellow volunteers, Etel and Isatu,
Yes,
for
thank
running
you
all
for
the
your
magic in the background. Thank you so much.
and the preparation. Yes, thank you.
Yes, absolutely. I agree. Thank you for being there. And then we also have our PMI brand ambassadors team that we want to advertise, and we have tonight Lorenzo with us. So if you have any questions about, becoming a PMI member, what are the benefits, what does it mean, etc., feel free to ask questions directly to Lorenzo during the networking session, if you are still with us after that, or via email to Alex, who shared his email address right there on the screen. So alexander.ziegler@pmiswitzerland.ch. And then we have a couple events coming up. So please join us on May 6th at the PMI Coffee Talk. It's virtual in English, always fun. So log on at 8:30 and with your cup of coffee and come with chat with other project managers. Then on May 10th, we have another virtual event. It's actually an open space, or 10th open space, on the topic of winning project politics. Should be quite interesting. So also virtual in English. So feel free to join us on the 10th. And then I really want to highlight this in-person event that's coming up on the 17th, entitled Design Thinking Toolbox for Project Managers. We have a team of certified facilitators who will make you practice finding human-centric problems and creating iterative solutions. So, and you walk away with concrete tips and tricks to bring back to your project work. So please sign up, take a look. It'll be at the 6th Convention Center on May 17th from 5:30. And then one more event, which should be really interesting as well. It's about team swarming, so working in a digital age. So I encourage you to sign up as well, be virtual in English, and on May 19th. So for all these events, feel free to sign up or read more about them on our events page on the PMI Switzerland website. And look forward to seeing you there. We also always call out for volunteers. This is a great experience. We are a fun team, so please look at our website and sign up to become a volunteer. And again, if you want to know more, we'll be hanging out in the networking session right after this presentation. And then don't forget to follow us on social media, LinkedIn, Facebook, all of them. Please follow our news and events there. And then a big shout out to our sponsors. Again, PMI is having those events thanks to our golden sponsor, PwC Switzerland, and our bronze sponsors, ProPMP and STS. If you're interested in sponsoring, please reach out using the email address sponsoring@pmiswitzerland.ch. And then, we always look forward to having your feedback. So please just take a couple minutes to send us your feedback via this survey. You have the URL here, and you can use the QR code on the side. That would be great. And for PMI members, here's the PDU claim code, which you can use to report your professional development units towards maintaining your certification. Hope this was really useful. With that, again, thank you so much, Rodolphe, and thanks for hanging out with us in the networking session just after this. So we're closing this presentation, but we are being available in special chat. If any of you want to hang out with us for 15 minutes, we have a speaker's lounge with Rodolphe, our speaker, and an ambassador's lounge with Lorenzo, our PMI brand ambassador. So click on the link or use the QR code. It's better on a laptop or a computer rather than on a mobile phone. The experience is possible still on mobile, but it would be easier, I think, if you're on a desktop. So click on this URL. If you have any trouble accessing this networking platform, this special chat, please message our host via the chat, and we will help you out. So I'll myself log in log in. I'll click on this URL and open special chat. You go there. So for those who are not going to this networking session, thank you so much for hanging out tonight, for listening in, and for